Hi, everyone. So hopefully you enjoyed the afternoon full of technical presentations. And I'm the last one today. And I'll be bringing everything together, right from what Alex said, Fred said, what you heard from Thomas and Andreas, and we will speak a little bit about how to apply that in a practical context in utility application of digital substations. So our main aim for today is to try and talk through the challenges that utilities face, both technical and related to people, when we talk about utility transition to digital substations. And then we will also talk a bit about the mitigation measures. So let's get started. For me, the way I see 60-50 substations is it's a combination of the traditional protection, automation, and control philosophy. And on top of that, we are putting the communication network or the Ethernet-based communication network. That's the main addition. So we are replacing hardwired communication with Ethernet-based communication. Now that's the technical side of things. But what I learned from my experience with digital substations over the time is that it also involves, and for really efficiently rolling out digital substations, what people have to, or utilities have to take care of, is the people element of it. Because the challenges that are technical, they can be easily overcome, but bringing the people with you is the only way to ensure that digital substations can really be efficiently rolled out on a larger scale on your network. So just to give you an introduction to what we will speak about today, there will be no true transformation within utilities to digital substations without empowering people. And OMICRON, at OMICRON, we empower utilities with our globally innovative products to test digital substations, but we also empower people with our know-how to apply that we apply in digital substations. And this is the know-how that I'm going to share with you today. And also we will look at some of those challenges that we face when we roll out digital substations, and then we will talk about the mitigation measures. So as mentioned, we will break down today's presentation into two categories, technology and people. And for me, this is really the crux of the story, that both of the things need to be taken care of hand in hand to really roll out digital substations. So since technology, as I said, technology is the easier part, we will start with the technical challenges. And I have categorized them into 4 quadrants based on the volume of work that these challenges require as mitigation measures, but also the complexity of them. So there are 4 main things we will touch upon today: building technical knowledge within your utilities or within your organizations. We will talk about specifications and policies. We'll talk about the tools that you need for digital substations and the market availability in general of IEDs and tools and how to approach them. So since the volume of work and complexity is the maximum in technical knowledge and building technical knowledge and specification and policies, and this is often where we see most challenges, I will start right with them. Now, Alex spoke to you a lot about standards, and he showed you lots of numbers, and then Fred spoke to you about standards. But let me just clarify, standards are not specifications. Standards are guidelines, standards are the way products are designed. Specifications is what you want. It's what you want from digital substations, how you want to deploy these standards in your digital substations, what best practices you want to apply. So there's a very big differences between standards and specifications. When we see conventional substations and utility applications of them with experience, there are lots of detailed specifications. But when we go to digital substations, we often see that specifications are done afterwards. They're often a mistake. And this is where challenges happen. And then we will talk about that in the next slide. But also what is to remember that while you go through this step by step into the world of digital substations, this is not just a one-time process. It's not just that you deploy one digital substation and that's done. It's a continuous process. So as you do more, you will learn more, and each of those steps will get optimized and improved with practice. So before you start with writing your specifications, you will have to know what standards and protocols you want to apply. And this is where the standards marry with your specifications. You look at the wide range of standards, you decide, talking to vendors, talking to consultants, or talking to experts, what are the standards you want to apply in your digital substations? And these are the standards you select as the first step of writing specifications. And this is something often people do. They know, utilities know quite in detail exactly which standards they want to apply. But then comes the valley of death. So this is a picture from my experience of working with 62950 over the last 6-7 years. What I see often is that the business case of why digital substations is required is quite clear to people. Alex spoke at length about it. But then everybody enters the engineering design phase. It's where you take the standard and you 650 standard and you really apply it to your engineering. And often that's the valley of death. Because utilities miss the specification stage, when they come to the engineering design phase, they find that they have landed up with data models that don't meet their requirements, and then you land up doing extra work or building an extra logic that you do not really require, or the vendors are not interoperable, not in the sense that they haven't applied the standard correctly, it's just that they don't meet your requirements. So I really want people to pay attention to this picture, because this is where we see most problems when it comes to digital substations, is the engineering design phase. And our experience is, once the engineering design phase is successfully implemented, then the testing and commissioning, operations and maintenance of digital substations are actually very small hurdles, and they're only the first time. And once you go through this process a couple of times, it becomes quite easier. So how do we ensure that our engineering design phase doesn't end up being the valley of death? So I always suggest utilities to specify what they want, in the sense to create a system specification definition file. I'll show you in the next slide how this file looks like, and then use such a specification file to do a template design. So you can, the 650 is it's a world where you can design your whole substation based on virtual IDs, based on protection functions, without even having a single ID in the room. So you should utilities should make use of that to first specify and understand what they really want from these IDs, and you can use virtual IDs, or in future there will be also possibility for ID specification definitions for that purpose. Then I encourage utilities to do a validation phase, where you can sit down with manufacturers and validate their real IDs against your virtual IDs and see if they really match your specifications. And only then select vendors that closely match your specifications and start with engineering design. Of course, I would say 100% matching will probably not be possible, but even if they come close and you know what are the limitations you have to live with, you are much better prepared, and you have actually overcome a lot of interoperability issues. So just a very quick snapshot of what a system specification definition looks like, and it's nothing really different from what you have been doing in conventional substations. So in a conventional substation, you would use the function description, or you would use ANSI numbers to define what functions you want to protect a specific feeder. And in 6150, you just translate them to logical nodes. The standard is very well defined. So when you search for a particular function, you will get all the names, and then you have to just put them, you have to attach them to virtual IDs or real IDs if you have them already available. And this is your first step of creating a specification. We don't have a lot of time to go through the details of it, but hopefully I've brought home the point that this is an important step before you really select IDs and before you start with engineering design. But also, what is also really critical, but also wonderful about 6150 is that from the day one of engineering design, you can validate your engineering design. That means, so I have shown our Station Scout tool here that Thomas Josik spoke at length about. One of the useful features of Station Scout, it allows you to visually assess the schema. So Station Scout, if it sees any problems with the design, right from the beginning, for example, you see some substation elements here where the logical nodes have not been assigned to any ID. You can also see issues with the IED data model itself. So from the day one, when you create your virtual IEDs and start with your design, you can import those files into Station Scout and start visually validating what you have created. And this is really wonderful because like in software development, you would do unit testing. This is unit testing of your design step by step as you build a large substation. You don't have to wait 6 months to finish your design and start validating it. Okay, now I've touched upon how you can start building your knowledge through standards, through specifications, through validating your specifications. Now we will go to the next very important aspect, tools. And as you see, I put the selection of tools as the less volume of work and less complexity because most of these things are already available in the market. You just have to go and pick the right tools. Now, I recently moved to Austria, and I can tell you how much tools are important in every aspect, and having the right tools is important because if you have ever tried to build a piece of furniture or build a home without the right tools, you already know how hard that is. It's same for digital substations. So when you go to move away from conventional to digital substations, in order to ensure that you have the same amount of reliability, availability, and maintainability in a digital substation, in addition to testing your protection, automation, and control systems, you have to use the right tools to ensure that you have a robust communication network, that your time synchronization is accurate and mostly available. And why this is important? Because when we move away from conventional to digital substations, one of the advantages is that you have more visibility. Your data model, your data communication, it's more visible. But in order to be able to make the most use out of this enhanced visualization or this enhanced availability of data, is that you have to have the tools to test them properly, and you have to test your communication network and time synchronization in a system-based manner before you start testing your protection, automation, and control systems. This is also one of the classic errors we have found utilities make, where traditionally, because protection, automation, and control systems are the crux of any conventional substation design, they go directly for testing it without testing the peripheral elements which are critical to the availability of the protection, automation, and control systems. And this is why we will touch upon today, and we will discuss what are the tools and how you can test your communication network and your time synchronization sources. And of course, I mentioned everything is based on a robust engineering design. So if you saw the presentation from Andreas or Thomas, you must have recognized that they all talk about the system configuration language. And that means that if you have a good design, then your testing already becomes much easier. And monitoring of the whole system. We won't be able to talk in detail about everything, but we are quite specialized here at OMICRON to deal with all these issues. So you can definitely contact us later if you want to know in detail about any of them, but I will definitely cover some of the topics. So when it comes to tools, I already spoke about the system specification. And in order to do system specification and system configuration, that is to generate the system configuration language file, you need a system configuration tool. And this is a critical part of any digital substation. There are many tools available in the market, such as Helix or SEL Manager, but also today in the evening event and tomorrow in the workshop, Jacob will be showing you OpenSCD, which is one of our open source system configuration tools. In conjunction with SCD, you would also need IED specification, IED configuration tools or ICTs, and these are all proprietary to the IED itself that will be available from the vendor. What you should do is be careful about what IEDs and what ICTs you use, because this is your interoperability moments between your SCT and ICT, and it should work. Otherwise, you will have engineering design issues. You, of course, need tools for fiber testing and cleaning, but I won't go into detail about those today. What I will focus on today is our internal expertise at OMICRON, testing, monitoring, and visualization tools, and of course, tools for cybersecurity. So when we move to digital substations, what's the first thing that changes? The fundamental thing in the protection chain that changes is that now we have the digital signals coming very close to the primary they are being generated there using something called a merging unit. A merging unit is an analog to digital converter. Fred spoke at length about the sample value streams and the sample value types, but it's very, and also Alex spoke about the transfer function. So it's critical to test the merging unit. It's critical to know that the first and the basic element of your protection chain, the measurement unit, is working properly. It's doing what it's supposed to do. And there, you can use a type of oscilloscope such as Daniel 400, and there you can compare the analog input that you inject into the merging unit to the sample value output from the merging unit, and you can compare them pretty much like you will look at an oscilloscope and ensure that your merging unit is really working properly. You can also play different COM-trait files on the CMC, generate different instances of transient behavior, and then you can also monitor the sample value output on oscilloscope. You can also feed that to an ID and see the protection function works properly. If you're working with LPITs, you will have to do this whole through primary injection. The second thing that you should look at in terms of use of tools and what your tools can do in digital substation is digital substations enable something called outage-less testing. And for me, this is the key advantage of having digital substations. So when we speak in the context of renewable generation and why digitalization is important, this is exactly the point. So renewable generations are intermittent. That means you don't want to take an outage on the network when you are doing maintenance, because if you take an outage, then you are stopping a wind farm from producing energy when the wind is blowing. And that means you are cutting off a generation, even if that generation was available. So more and more renewables are getting integrated onto our network everywhere, and they're becoming intermittent. It's important that we have outage-less maintenance of substation secondary systems. And in order to enable that, 6250 edition 2 introduced something called simulation and test. That means you can keep your protection ID in operation, one of your redundant protection IDs in operation, the one you see with the mode on here. You can take the second protection ID out of operation just by putting it in a simulation mode, just by putting the simulation flag to true and putting it in a test mode, and test everything by just connecting a test set. You don't have to disconnect a single fiber. As long as your interface to the primary is put in a test blocked mode, I apologize, there is a mistake on the slide. As long as the interface to the primary is put in test blocked mode, this mode should be test blocked. Even if it's physically wired to the primary, it won't execute the commands. So it's important to know that these features are available. It's important that you know that the test sets can enable testing in this kind of an environment, so that you really can make you can take the advantage of building as digital substations and maintain the availability of your network. Something also that will become quite critical in future when we talk about wide area network schemes, or we are talking about schemes where the power system parameters are changing a lot, and you really don't trust the settings in your ID, is system-based protection testing. So we have a tool called Relay Sim Test. What it does is that it tests the performance of the relay or the accuracy of the operation of the relay against real system parameters. And this is a useful tool, again, in the context of intermittent generation, because when things change on the power system constantly, you should be able to test the relay against different system conditions and see if the settings or the setting groups you have set for it do match the system conditions. Again, a very powerful tool when you talk in the context of digitalization, intermittent generation, and how having digital substations and being able to test it in the power under the different power system conditions is important. Now, I spoke about time synchronization and the importance of it in a digital substation. Now, I'll touch upon a little bit about how PTP works, or PTP Best Master Clock Algorithm works. So basically, PTP allows you to keep your substation synchronized in a very good accuracy for, depending on the type of oscillator, for hours or maybe days, even if you don't have a satellite signal. So that's the beauty of it, because GPS spoofing, GPS failures are commonplace. And what it does is that as soon as a clock fails with the best master clock algorithm, it selects a second clock, a redundant clock as the master. And even if this clock is not present, if this clock has a good, the main clock has a good oscillator, it can keep the substation synchronized in microsecond range, depending on the type of oscillator, even for hours or days. That means you have enough time to go to the substation and fix the GPS signal, and you don't lose the availability of your substations. And why I relate PTP to the availability of substations, or time synchronization to the availability of substations, because merging units, they need a very high accuracy time synchronization to be able to generate sample values that are accurate enough to make correct protection decisions. And that's why testing PTP also becomes important, and you need the right tools for it. So when you are building a digital substation, make sure that you couple of times create failure scenarios and see how the switchover between clock or clock classes, or from satellite to oscillator back to satellite, happens. And then your IEDs all stay stable and they perform the way that they are supposed to. And we used NU 400 for this purpose, and it's proven quite successful. And I encourage you highly to do this test. The second thing I mentioned is communication network. Now, when you replace your wiring with Ethernet-based communication, the first question a lot of operation engineers or commissioning engineers ask us is, how do I know that I could go with a multimeter before and I could test the output or the input, but I have nothing like that now. So how do I know that this communication of trip signals, events, is actually of good quality? Now you can use two tools for this. The Station Scout shows you in real time how the communication happens. So you can use Station Scout to do point-to-point tracing, but you can also use network monitoring tools to really look at all the quality flags that come with GOOS, with sample values, with PTP, and make sure that your quality of the signal or the quality of communication always stays good. And such monitoring tools are very powerful, because when there's a quality change, it will tell you, and you can also record, do a short pickup recording, and then you can analyze this at a later stage. So suppose you are doing a major protection test and you don't have enough time to really monitor your communication network, you can keep an unsupervised recording happening in the background, and every time there is a problem with the communication, it will create a recording for you that you can analyze later on. So such kind of communication network testing and tools to enable such testing is also quite important in digital substations. Same for redundancy. Because everything is now based on a communication network, we build in redundancy, but it's also important that you do test the redundancy before you commission your substations. Okay. I spoke about Station Scout and how you can monitor in real time. This is something that can replace this kind of signals tracing, that can replace your point-to-point testing that you would do in a commissioning scenario in a digital substation. The good thing about digital substations is you don't even have to wait to go to site to do this testing, because everything up to merging unit can be connected up with fiber offsite. I highly encourage utilities to do such tracing even offsite, and finish 85% of your test offsite, so you spend really less time on site doing your commissioning test. That's another advantage of digital substations, that most of your tests can be done offsite, and you can identify your errors and fix them offsite before you go on site, so you can save a lot of time on site, and that is also quite a bit of money. Thomas already explained this testing of gateway and HMI. I won't go into the details of it, but just remember, you also need tools for it, tools that can automate tests and then make your life easier. And then finally, Andrea spoke quite in detail about cybersecurity and why it is important in digital substations. So I just want to, again, refresh your memory that this is also quite an important tool and something to be considered from day one when you're building digital substations, of how you're going to secure it afterwards from any attacks. Okay, the last technical challenge that I want to touch upon is market availability. And this does play a role. So here I've shown you template system architecture. I've taken this from LANDSNET Iceland, who are currently building quite a few digital substations on their network. And I will talk about some of the availability issues that they are facing or we are facing in general in digital substations. For example, finding redundant clocks with good oscillators. There are some challenges there, and that is and not many, maybe many players. Design for substation environment, that's something we are looking at. And of course, switches that have the correct filtering features that can be easily configured, and monitoring functions that can tell you in real time if there's a failure of communication, and they can self-monitor themselves. Then vendor interoperable IDs, of course, as we spoke about specifications and selection of IDs, but vendor interoperable IDs are also sometimes, for certain cases, difficult to find. This is getting really better with time, but again, market availability plays an important role in it. And then, of course, there are some key applications like metering applications, traveling wave, and we are still waiting for a good, easy to configure solution in this for these kind of applications. So what I meant to say that even if you make really good specifications, you have to kind of find the balance with what's available in the market. What I've seen in the last 5-6 years is that the market has evolved really rapidly and evolved fast, but this is kind of a chicken and egg situation. So it's like if you build a lot of digital substations, you'll have a lot of players who are building the right IDs for you. If not, then it's a bit slow. So we hope that this will change as digital substations become a commonplace in future. Okay, so I promised I'll come to people somewhere. And this is interesting. So when I started with digital substations, for me, the people factor wasn't that important because I was more focused on technology. But I just know that that philosophy doesn't work. So my colleague Fred has coined a term called social engineering, and I really like it because along with doing your engineering design for digital substations, you have to do the social engineering part for digital substations as well, because that's what will ensure that your people, the people in your organization, your colleagues that are really responsible for the substations come with you, and they really partake in this entire discussion of how digitalization will happen in future. And we could really spend hours talking about people issues, about misunderstandings, or what's maybe scares them to move towards digitalization, or you can have people who are totally enthusiastic about it, but you need to bring everyone with you. So we will, again, in the same categories, discuss what's the volume of work and what's the complexity of bringing people with you and how you can do that effectively. So we will start with the ones with the less volume of work but more complexity, which is creating interdisciplinary collaboration for building digital substations or enabling digitalization, and the initiative. So traditionally in utilities, you will have discrete teams which do different functions. And in a conventional substation, to a degree, they can work independently. But in digital substations, because everything is related to the data model, is related to how the substation is designed. So when you design, you need to think about how this will be operated and maintained. You need a holistic approach to digital solutions. And what many utilities who have successfully deployed digital substations done, they have started something called a Digital Substations Initiative. And this is then controlled or regulated through a digital strategy group. And there they have representatives from interdisciplinary teams, or this is an interdisciplinary team with representatives from different teams, and they work together in that environment to write specifications, do trials, and this is how a lot of utilities have approached this. And what we do, or what we have seen often, that there are 4 main tasks such an initiative or a group has to do. They have to create the right specifications and policies. They need to do the right approvals and create offsite test facilities. We will talk about that in a minute. They need to think about the training and development of their colleagues in the organization. And of course, there needs to be a process change of how things were done in the past and how they will be done in the future. And OMICRON, we have a small team here called Application Services. We support utilities in pilot projects to enable these 4 steps. We work with such strategy or initiative groups to establish these practices in utilities so that they can easily transition to digital substations. So now we'll talk about building confidence. And here also we have made some good experience. And the first thing I want to touch upon is learning by doing. Often we have questions, and then we have theories, and then we have hypotheses, and we wonder how things could be. We read about things, but there's a saying in India, and I think it's in many countries, that the apple that you read in the book is different than the apple that's in the orchard. So what that means is that you can read and you can hypothesize and you can simulate and study, but unless you really try things, you never know how it's going to work. But in order to be able to attempt such things, you have to know what you are looking at. So first step is training. First step is to look at what's this new digital technology? How do we go about it? And what I have seen often is that utilities do block trainings for 2 weeks, and then for 6 months, there is no hands-on practice, and they forget really what they have learned. So in order to break that bad chain of doing block trainings and not having hands-on practice, we encourage utilities to build their own offsite test setups. And what it enables you to do is that, first of all, your engineers have a safe environment, a secure environment to try any new ideas they have or anything they want to learn about digital substations without really trying it on site or on a real project where the pressures are different. But also it enables to really for them to touch and feel things, to look at tools, to try different concepts and learn from it. So without this, there's always a lot of hypotheses which can't be really proved up till you put an idea into operation. So whether it's possible to create it within your own organization or you have access to a offsite test setup, it's a very critical element of digital substations because you have the flexibility to test everything offsite and learn from it. You should make use of it and try all your new philosophies and how you move towards digital substations in a controlled and manner to manage your risks. Do build an offsite test setup. And this will also fill engineers with the confidence that when they're going to site, they have already played with such a system and they know what to do. Then we'll talk about a very important element of digitalization, and that's communication. And this is not Ethernet-based communication or communication network, it's just communication amongst people. And who can utilities communicate with? First of all, utilities can communicate with vendors. And this is not just giving specifications, but this is where I would say co-innovation. I think digital technologies or digitalization puts everything into a different perspective. In order to really create something good, rather than just waiting for a vendor to deliver something for you, we have to be more active, or utilities have to be more active to talk to vendors and really understand where the standard is going, what they can do, and co-innovate. And the more co-innovation happens, like when we did fitness, it was really a great place to learn and to create new things because we all worked quite closely together and we co-innovated. There are lots of groups, there are lots of good papers published. That's another thing to look at before you jump, when you encounter a problem, who has tried this, who has written something about it. And trust me, our engineers in this industry are really good at writing papers. So you will find tons of information, but also you can contact people who manage these standards, do interoperability tests, and you can co-standardize. Utilities have to also be more active in the standardization process. And the last thing, which I've also missed sometimes, is utilities talking to other utilities, and that's called collaboration. So all of this is actually collaboration, but what I mean to say is that I see lots of pilot projects coming up, and I feel like the time for pilot projects in digital substations has kind of come to an end now. I think everything that needs to be tried has been tried somewhere. It's time to learn from each other, talk to each other, and the more we communicate, the more solutions we will find, or at least we will avoid the same mistakes that others have made. So that's really the end of my presentation. I will be happy to take any questions after this, but just to summarize what I've said to you right now, Digitalization and digital substations will be a commonplace, or they are a commonplace, or at least they are under consideration by many utilities, especially in transmission sector. There are challenges, but these challenges can be mitigated, and often people have faced those challenges and they have written about it. So it's all a matter of collecting that knowledge and applying it. There will be some initial investments required, and I've written invest here a lot of time, but this investment is nothing compared to the savings that you will ultimately make with digital substations in later time. So all in all, digital substations will drive decarbonization, which is our duty as vendors, as utilities, to make happen, to reverse some of the bad effects of climate change that Alex spoke about, and we really can work together to make it happen. So with that, I'll bring my presentation to an end, and I think I have 8 minutes for questions. Fred?
Thank you, Priyanka. Yes, you have 8 minutes for questions. We did not get any here through the Q&A, but since I know that you did this kind of collaboration, that you had a couple of visits from utilities when you were running your projects, could you maybe give us an idea how this worked out and what happened there in terms of information exchange?
Okay, so this is going back to the time when I was not working with OMICRON, but working with SP Energy Networks in my previous job, and when I was working on fitness. But of course, OMICRON and SP Energy Networks were closely involved in this collaboration. And what we really saw is that once we finished the trial, I finished commissioning fitness at Wishaw in Scotland, SP Energy Networks opened the door to utilities, manufacturers from around the world, and we got lots of visitors. So pretty much every month we were doing 1 or 2 visits. And what utilities were really keen to see is a real application. They really, as I said, this feeling of really realizing things can happen when you touch and feel something rather than looking at PowerPoint, that was the wow factor. And they came and they saw the comparison of the copper cables in a conventional side of the same substation to the digital substation, which was based on fiber. They asked many questions to OMICRON about testing. So Ali, who is my colleague, was really helping me there. Show them how we tested the substations. They had lots of questions about SCADA testing. We also had LPIT's installations in fitness. So they also wanted to know how this whole chain works. So basically, it was a real application of digital substations that wowed everyone. Okay. Fred has just told me we have maybe another question.
Yes, we have another question, and this is going deep. It's really your assessment. How much is the challenge coming from the technology and from the equipment, which has to be good for that purpose? And how much is the challenge coming from the technical people and also the management behind the technical people to apply that?
I will start with a classic statement that everybody who knows Alex knows: it depends. It really varies from utilities to utility. But the market side of things, or I'll start with the technical side because I really find that quite easy and to give generic answers about. The technical side of things is that it's like a market, technology push and a utility pull. So I believe that the more digital substations are being built, the technology is getting better and better. So that is really diminishing as a factor to stop digital substations being rolled out on a large scale. So if we take, for example, LANDSNET, for example, or SP Energy Networks, as they worked through their projects, vendors really stepped up and delivered solutions. Now, when we talk about people, management, technical, and everything, we see often a lot of resistance, and this is not to play a blame game. This is really from experience. We see often a resistance coming from operational people who have to maintain the substations. And for them, it's hard because if someone else is designing the substation, which is completely a new philosophy in terms of communication and network, and then they have to take care of it when at 2 o'clock in the night there is a failure somewhere, they become a bit, how to say, wary of where this is going. And that's we have seen a challenge. From the management side, I have often seen quite a bit of interest because of the decarbonization targets and the regulations changing that push utilities towards regulations. But management have to bring the people with them. So if there is one group that's saying this is a great idea, but one group that's saying that's going to affect us and the reliability in a regulator environment, this can become a problem. So the way to come across, change all this is communication. And this is why I spoke about communication in detail. You have to involve the people who will maintain the substations from day one when you design it. And only this kind of interdisciplinary collaboration from the beginning when you write the specifications can avoid these challenges. So I hope I answered your question. However, this varies from utility to utility, so this was more of a generic overview.